Today we're going to talk about lesson 4.10, which is on transforming linear functions. In this lesson today, we're going to describe how changing slope and y-intercept affect the graph of a linear function. So we'll talk about family of functions, parent functions, transformations, translations, rotations, and reflections in this lesson. So who uses this? Business owners can use transformations to show the effects of price changes, such as the price of a trophy engraving. And we'll see that in example 5. So a family of functions is a set of functions whose graphs have basic characteristics in common. For example, all linear functions form a family because all of the graphs have the same basic shape because they're a straight line. A parent function is the most basic function in a family. For linear functions, the parent function is f of x equals x. The graph of all linear functions are transformations of the graph of a parent function, f of x equals x. A transformation is a change in position or size of a figure. So you could be moving it up, down, left, right a little bit on the graph. You might be stretching it to make it a little bit bigger or shrinking it to make it smaller. You might be rotating it a little bit, reflecting it. So there are 3 types of transformations that we're going to talk about. Translations, which is going to be moving it. Rotation is turning it. And then reflection is flipping it over. So think about your reflection in the mirror. So in this graph here, we have 4 functions listed and their graphs. So we have g of x equals x plus 3, f of x equals x, h of x equals x minus 2, and k of x equals x minus 4. Remember function notation, f of x, g of x, and so on can be used in place of y. And you can do different letters, f, g. See, we have g, f, h, k. Doesn't matter what that first letter is. And the letter that's in the parentheses is the variable that we're dealing with in our function. So you should notice here that all of these graphs are parallel. The slopes are the same. But what's different here is the y-intercepts. We have 3, 0, -2, -4. So the graphs of g of x equals x plus 3, h of x equals x minus 2, and k of x equals x minus 4 are vertical translations of the graph of the parent function f of x equals x. So x plus 3 was moved 3 units up, x minus 2 was 2 units down, x minus 4 was moved 4 units down. So a translation is a type of transformation that moves every point the same distance in the same direction. You can kind of think of a translation as a slide. You're just sliding it up or sliding it down. Okay? So when a y-intercept b is changed in the function f of x equals mx plus b, the graph is translated vertically. So if b increases, the graph translates up. So if it increases from whatever their original was. And then if b decreases, it moves down. So we're going to go ahead and look at example 1. Translating linear functions. So it says graph f of x equals x and g of x equals x minus 5. Then describe the transformation from the graph of f of x to the graph of g of x. So let me get 2 different colors here so we can easily see the graph. So our first function is just f of x equals x. So when I graph this, f of x equals x, my slope, m, is going to be 1, or you could write that as 1 over 1, -1 over -1. That's going to help you form your graph. And then there's no plus b here, so b is going to be 0. Okay? So that means I'm going to start out my origin. And then I go up 1, right 1, up 1, right 1, up 1, right 1, until I form the upper half of my graph. Then going in the other direction, down 1, left 1, down 1, left 1, until I fill out the lower half of my coordinate plane. And then I'm going to connect the dots to form my graph. So that is f of x equals x. Now my second graph is going to be g of x. I was going to write f of x, sorry. G of x equals x minus 5. So here my slope is still the same. Slope is 1, or 1 over 1, negative 1 over 1. But this time I have a b. My y-intercept is negative 5. So where I start, I'm going down 5. So 1, 2, 3, 4, 5. There's my intercept. And then I form the rest of my graph. So I go up 1, right 1, up 1, right 1, until I form the upper half of my graph. And then I go down 1, left 1, down 1, left 1, until I fill up the whole graph. And then I'll connect my dots. Draw arrows at each end, and this is g of x equals x minus 5. Okay, so you can see how these two graphs are a little bit different. The graph of g of x equals x minus 5 is just shifted down 5 units. It's a translation of the graph f of x 5 units down. Okay. Now you'll see in your book you can also graph it on a graphing calculator if you'd like, but graphing it on a piece of paper, you get the same result. So now we have a check it out problem. It says graph f of x equals x plus 5 and g of x equals x minus 2. Then describe the transformation from the graph of f of x to the graph of g of x. So go ahead, take a moment, pause the video, try this one on your own, and then resume when you are ready to check your answer. So first I have f of x equals x plus 4. So my slope is 1, my b, or my y-intercept, is going to be 4. So I'm going to go up 1, 2, 3, 4, and then my slope, up 1, right 1, up 1, right 1. Other direction is down 1, left 1, until it fills up the entire graph. And then you're going to connect your dots to form the line. We're going to repeat this process for our second graph. Our second graph is g of x equals x minus 2. Slope is 1. Y-intercept b is negative 2. So I'm going to go down 1, 2. There's my intercept. Then I go up 1, right 1, up 1, right 1. And then in the opposite direction, down 1, left 1, down 1, left 1. And then here I'm going to connect my dots to form my graph. And now I need to look at my graph and see what's happening here. Okay, so this was my f of x plus 4. G of x equals x minus 2. So here, from my green line to my orange line, I'm going down 1, 2, 3, 4, 5, 6 units. So from f of x to g of x, we are translating 6 units down. It is translated 6 units down. So those are our translations. So now moving on, here we have another example. The graphs g of x equals 3x, h of x equals 5x, and k of x equals 1/2 x are rotations of the graph of f of x equals x. So the parent function is f of x equals x, and a rotation is a transformation around a point. You can think of a rotation as a turn. So the y-intercepts are the same, but the slopes are different. Okay, so you see how they're all sharing this origin. They're just turning different directions depending on what the slope is. Okay, so when the slope of m is changed in the function f of x equals mx plus b, it causes a rotation of the graph around the point 0b. So whatever your y-intercept is, that's going to be where the rotation is happening. That's the common point. And then this is going to change the line's steepness. So let's go ahead and look at example 2. So we have f of x equals x plus 2, and g of x equals 2x plus 2. And then we'll describe the transformation from the graph of f of x to the graph of g of x. So starting with f of x equals x plus 2, my slope is 1, and my y-intercept is 2. So y-intercept is up 1, 2, and then my slope is 1. So I'm going to form the upper half of my graph by going up 1, right 1, and the lower half down 1, left 1. And then I'm going to connect my dots to form my graph for f of x. Now my second graph is g of x equals 2x plus 2. My slope here is 2, which means 2 over 1, or negative 2 over negative 1. And then my intercept is 2. Okay, so with rotations, you share the same intercept. Okay, so here's 2. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. So that's the upper half of my graph, sharing the same point here. And then I'm going to go down 2, left 1, 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 down 2, left 1. And then I'll connect my dots to form my graph. So these are the two graphs of these functions. So we have f of x here in this blue, and then g of x. So what's happening here is they are rotating. They are still sharing this same point here. This is 0, 2. They have the same b, or the same y-intercept. So they're rotating the graph around this y-intercept. And then just to compare the slopes, g of x is steeper than f of x. So that is how you would look at example 2. There is a check it out problem for you to do, so go ahead, take a moment, pause the video, and try this one on your own. Resume when you're ready to check your answer. So here we have two graphs again. We have f of x, which equals 3x minus 1. So my slope is 3, or I could write that as 3 over 1, negative 3 over negative 1. And then my y-intercept, my b, is negative 1. So starting with my y-intercept, so negative b, or negative 1 is b, so that's going to be right here. And then I'm going to go up 3, right 1, up 3, right 1, up 3, right 1, up 3. I'm just going to go off my graph a little bit so I can draw a straight line. And then down 3, left 1, down 3, left 1, down 3, left 1. So I'm going to connect my dots. And that's my graph for f of x. And now I'm going to repeat this process with g of x. So g of x is 1/2 x minus 1. So our slope is 1/2, or you can write that as negative 1 over negative 2. And our y-intercept is negative 1. So they share the same y-intercept, so right here. So I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Other direction, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. and then I'm going to connect my dots to form my graph. So now I need to compare them and see kind of what's going on here. So in this graph, we are rotating around this point right here, our y-intercept. And our y-intercept is 0, -1. So it's rotating around 0, -1. Okay? And then here, f of x is steeper than g of x. So we're going from really steep to not so steep, if you're thinking about it in terms of moving from f of x to g of x. So it rotates, we have a rotation, it's rotating around 0, -1, and then f of x is steeper than g of x. So now we're going to get into reflections. So the diagram shows the reflection of the graph of f of x equals 2x across the y-axis, producing the graph of g of x equals -2x. A reflection is a transformation across a line that produces a mirror image. You can think of a reflection as a flip over a line. So here, we're flipping over the y-axis, so everything on this side of the graph is the same as this side. Okay? Our original function is this f of x equals 2x, and then if I would put a mirror right here, it would flip it on over and have the slope go in the opposite direction. So when the slope m is multiplied by -1 in f of x equals mx plus b, the graph is reflected across the y-axis. So we're going to go ahead and look at two examples. In example 3, part A, well, before we get into part A, it says graph of f of x, then reflect the graph of f of x across the y-axis. Write a function g of x to describe the new x, or the new graph. So here, f of x, okay, we are going to go through the origin, and then our slope is 1. So let me graph this guy first, and then we will reflect it across the y-axis. So connect your dots so it forms a straight line. So this is my f of x equals x. Now, when I go to reflect it, just like we saw on that last slide, our slope m is multiplied by -1. So if our slope here is 1, we're going to take that and multiply it by -1 to get our new slope. So we get -1. So that means our new function, we can name it g of x equals -x, or -1x. So they're going to share the same intercept. Okay, so they're going to share this origin as the intercept, except our slope is different. So our slope is -1 over 1, or you could write that as 1 over -1. So I'm going to go up 1, left 1, up 1, left 1 to form the upper half of my graph. And then the other direction, we go down 1, right 1, down 1, right 1 to form the right half of our graph over there. And then we're going to connect the dots to form our line. So that is the graph of f of x and g of x when we're reflecting f of x. So f of x was the orange, and then we reflected it across the y-axis to get our g of x. Now we're going to do the same thing in B. We have f of x equals -4x minus 1. So first I'm just going to graph that -4x minus 1. So our slope is -4 over 1, or we could write that as 4 over -1, and our y-intercept B is -1. So I'm going to go down 1 to plot my y-intercept. Let me scoot that up a little bit so you can see it better. And then I'm going to use my slope to form the rest of my graph. So I'm going to go up 1, 2, 3, 4, left 1. Up 1, 2, 3, 4, left 1. Up 1, 2, 3, 4, left 1. And then I'm going to go down 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, right 1. And then I'll connect my dots to form a straight line. Or try to form a straight line without a straight edge right now. So then from here, to reflect it, we are going to multiply our slope. Our slope is -4. So I'm going to multiply -4 by -1, and that gives us a +4. Okay, so what that means here is our g of x, so this is going to give us our g of x, is going to be +4x, and then you keep the same intercept, so +4x minus 1. So our slope is 4, and our intercept is -1. So same intercept, except this time I'm going up 4, right 1. Up 4, right 1. Up 4, right 1. And then down 4, right 1. Down 4, right 1. And then I'll connect my dots to form my graph. And that is what your reflection would look like for that example. So now there is a check it out problem for you to try. So go ahead, take a moment, try this problem on your own, and then resume when you're ready to check your answer. So it says graph f of x equals 2/3 x plus 2. Then reflect the graph of f of x across the y-axis. Write a function g of x to describe the new graph. So we have f of x equals 2/3 x plus 2. So our slope is 2/3, or you could write that as -2 over -3. And our intercept is 2. So I'm going to graph my intercept first. Oh, that's a -2. I apologize. I got to go up first. So up 2. So that's going to be our 0, 2. And then I'm going to use my slope. So up 2, right 3. Up 2, right 3. Up 2, right 3. And then in the opposite direction, we're going to go down 2, left 3. Down 2, left 3. Down 2, left 3. And then we'll connect our dots to form our graph. Then we need to get our g of x. So remember, to get our g of x, we take our original slope, the 2/3, and multiply it by -1. So we get -2/3. So g of x is going to equal -2/3 x plus 2. So that means our slope can either be -2 over 3 or 2 over -3. Intercept b is still the same. So that means I'm going to go up 2, left 3, up 2, left 3, up 2, left 3. Other direction, down 2, right 3, down 2, right 3, down 2, right 3. And then we'll connect our dots to form a straight line. So that is what our graph would look like for this example. So we took f of x equals 2/3 x plus 2 and reflected across the y-axis. So you just take your slope and multiply it by -1 to get your new graph. You keep the same y-intercept. So now we're going to look at example 4. In example 4, we're going to see multiple transformations of linear functions. So it says graph f of x equals x and g of x equals 3x plus 1. Then describe the transformation from the graph of f of x to g of x. So let's start by graphing f of x equals x. Remember, slope is 1. Y-intercept is 0. So we're starting at the origin, going up 1, right 1, and in the other direction, down 1, left 1. So I'm going to connect my dots to form my graph where f of x equals x. Our second function here is g of x equals 3x plus 1. So our slope is 3 over 1, or negative 3 over negative 1, and our intercept is 1. Okay, so our intercept is actually changing this time. So we're going to go up 1 to start, and then slope up 3, right 1, up 3, right 1, up 3, right 1, other direction, down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1. And then from here, connect our dots to form our graph. So here is what our graph would look like. So what's happening is our slope changed. Okay, our slope was 1 to 3, and our intercept also changed. So here we multiplied f of x by 3 to get h of x equals 3x. This rotates the graph about 0, 0, and makes it steeper. Okay, so we started with the green line, and then we went steeper. Then we translated it. We moved it up 1. Okay, so we multiplied it by 3 and then translated it up. So we rotated it and then translated it. So here the transformations are a rotation and a translation. So now there's a check it out problem for you to try. It says graph f of x equals x and g of x equals negative x plus 2. Then describe the transformations from the graph of f of x to g of x. So go ahead, take a moment, pause the video, and try this one on your own. Resume when you're ready to check your answer. All right. So first graph, f of x equals x. Slope is 1, intercept is 0. So you should be very familiar with how to graph this graph from this lesson so far. So intercept is at the origin. Go up 1, right 1, or down 1, left 1, and then connect your dots to create your graph for f of x equals x. Then we are going to graph our second function, g of x, which equals negative x plus 2. So our slope is negative 1 over 1, or 1 over negative 1. Our intercept is 2. So we're starting at 0, 2, and then we're going to go up 1, left 1, up 1, left 1. In the other direction, we're going down 1, right 1, down 1, right 1. All right, so that's what our graph looks like there. So, a couple things to notice. First, our slope is changing. It's going from 1 to negative 1. So what we're doing with our slope is we're taking this slope and multiplying it by negative 1. So we are reflecting, or we have a reflection across the y-axis. Then the other thing to notice is our b's are changing from 0 to 2. Our y-intercept is changing. So that means we are going to translate 2 units up. So we have a reflection across the y-axis, and then we have a translation that goes 2 units So this one's a reflection and a translation. So now we have one more example, example 5. It says a trophy company charges $175 for a trophy plus 20 cents per letter for the engraving. The total charge for a trophy with fx letters is given by the function f of x equals 0.2x plus 175. How will the graph change if the trophy's cost is lowered to $172? If the charge per letter is raised to 50 cents. So on the graph says the blue line is right here. That's going to be our f of x. Okay, we have an intercept of 175, and then we're going up 0.2. So up 1, right 5. Okay, so 0.2 is 1 over 5. Then if it's lowered to 172, the g of x would be 0.2x plus 72. So the only thing we changed was our intercept here, the 175 to 172. So slope's going to be the same, just our starting value is different. So that's our g of x. It's just translated 3 units down. The next transformation is changing our slope. So we're raising the price to 50 cents. So we have h of x equals 50.5x plus 175. So the initial value is the same, the 175, just we're having a steeper slope. So the original graph is just rotated around that y-intercept 0, 1, 75. So that's what that example would look like. Example 5, how would the graph change if the charge per letter is lowered to 15 cents, if the trophy's cost is raised to $180? So we have these 3 graphs that we're going to do. So first I'm going to graph f of x, which equals 0.2x plus 175. So remember, the 0.2 is equal to 1/5. So I'm going to start at 175. And then I'm going to go up 1 over 5. So I went up to right 10 because the scaling is 2 blocks this way, and then 2 for each this way. And then I'll go up 2 again, right 5. So this is for my f of x. My next graph, it says, what if we lowered it to 15 cents per letter? So my next one I'm going to say is g of x. G of x is going to be 0.15x plus 175. Okay, so 0.15 is actually equal to 3 over 20. So here I'm starting at 175, and then I'm going to go up 3, right 20. But I don't have 20 down here, so I'm just going to split this in half. So this is going to be 1.5 over 10. So I'm going to go up 1.5 over 10. So the graph will look something like this. So g of x is a little bit less steep because it's cheaper per letter. And then our last graph, we're going to say h of x, if the trophy's cost is raised to $180. So we're going to have the same slope, so the 0.20x plus the y-intercept is changing, so 180. Remember, 0.2 is 1/5. So I'm going to start this time at 180. I go up 1, right 5. Up 1, right 5. I just want to give you an idea of what it would look like if it went off the graph. So it's going to look like that. So it has the same slope as our f of x. Its starting value is just different. So it was translated up 5 units. So from f of x to g of x, we're just rotating it around the 0, 1, 75. And then from f of x to h of x, we're translating it up 5 units.